Now, all of that is squared, yes? Where does that 2 go? To everything. So that 2 goes to that 2, right? What's 2 squared? 4. What's x to the 4th squared? X to the 8. What's y to the 1 squared? Y squared. 4x8 y2. 4x8 y2. Now, once again, I say to you, this, one sec, Riley, this, hideously ugly. This, 2x to the 4th y squared, easy or difficult?
It looks difficult, but in reality it's easy.
Easy, right? This, x to the 5th over x to the 4th, difficult? No. This, x to the 4th times x, difficult? No. So I ask you again, where is the difficulty here? It's looking at a big picture and trying to go at it straight away. If I asked you to do a 1,000-piece puzzle, would you dump all the pieces out on the ground and just, oh? Or do you start with a system? My system is to start with the edges. Then I am not looking at 1,000 pieces. I am looking at maybe 100. And they all have a nice little edge on them. I don't even start with the edges. What do I start with? I find the 4 corners. Now I'm only looking for 4 of those pieces. I'm not looking at 1,000. I'm looking at 4. Picking up what I'm putting down? Stop looking at the big picture and apply the math that you know in a situation that you know and see if that leads you to the next step. Aight? Riley.
Okay, so if it's like, it's like 2x and then y squared.
So that?
Yeah, and then it has a bracket and then 4 again. How is the x supposed to be 2? Does it need to be x squared?
This x right here has what exponent? 1. So it's squared. So it's going to be x times x. What this means, Riley, what this means is I'm taking 2x y squared and I'm squaring it. So I'm going to multiply it by itself again, right? So 2xy squared. What that means is I have 2xyy, yes? And this is 2xyy, right? 2 times 2, 4. My computer is frozen, but you know what I'm doing. X times x, x squared. And y to the 4th. This is why I go out of my way to spend that whole first day writing it all out. So I can prove to you guys that if you actually understand what's going on, then all these shortcuts make perfect sense. And even if you can't remember all the shortcuts, you can always write it out. Right? So let's look at this next one. Again, looks disgusting, yes? So, by the way, you can mark it. If you got D, you got one right. Let's look at this one. Choose one thing and fix it. Is there any right way to spot to start? Of course not. I start in the numerator in this question just because it's the first thing I see. What does that 4 do to everything? So I get x to the 8 and y to the 4 over. Now look at the bottom. Are there any other 2's? No. So is 2 changing? No. Are there any other x's? How many? 6. Are there any other y's? How many? 6. Y 6. Now, are there any other numbers? Nope. So 2 stays on the bottom. Can I do anything with my x's? What? What is 8 minus 6? Positive 2. Are positive 2s allowed? So they don't need to go anywhere. So it's x squared. What about 4 and 6? That's going to be negative 2. So if I left it up top, it would be negative 2. Is that allowed? No. Where does it go? And there is the answer. Please tell me that when you break it down into steps, you are all metaphorically slapping your heads the way I do right now. Right? Because step by step, it's not hard. Choose a law and follow it through. No problem. Okay. This one looks a lot like the first one, yes? And in the first one, I took care of everything in there, didn't I? So, do you think that'll work here? What do I do with all the numbers? Multiply them. That's 2 to the 1 and 2 to the 1, because they're the same base, aren't they? So that's 2 to the 2, yes? Everyone agree? Okay, so it's 2 to the 2. What do I do with the x's in the top? You're going to add them. So what do I got?
4.
X to the 4th. Why? Because 3 and 1 is 4. What do I do with the y's? Add them to get what? Y7. Not complicated, is it? That's the very first thing on the very first page of exponents we did that you all did well on, yeah? Okay, so now let's go down to the denominator. Do I need to make any changes on the bottom right now? No, because there's no other numbers down there. Now, what's that? 2 squared, which is 4. What's that? X. 4 minus 3. What's that? Y4. Yeah? Great. That is everything in the middle. Is that easier to deal with than that? Yes. Is that difficult to find? Not if you go step by step. Now you'll notice that whole thing has a 4 outside of it. Where does that 4 go? Everywhere. So it goes to the 4 first. 4 to the 4th power is 256, if my stupid computer ever works again. 256. X to the 4, y to the 16. There it is right there. Now by this, 4 looks barf-tastic, doesn't it? 4 actually looks difficult. I'm even concerned about 4. So what do? I find a way to make it simpler. I notice, personally, that I can tidy up those brackets, can't I? Well, let's tidy that up. Let's start with that and see if that helps me along the way. Y, x minus 2 over x minus 1. Let's tidy that up. 2 and nothing. So it's 2. What do I do with the x and the x to get what? X6. Excellent. And what do I do with the y and the y? Negative 3, negative 4 plus 3 is y to the negative 1, yes? And all that is squared. Agreed? Have I gotten rid of my brackets? No. But I know how to do this. What do I do with that 2? I put it through to all the bracket, yes? So what do I get? What's the first one? 4. 4. Then x what? 12. Then y what? Negative 2. Now, have I gotten rid of my brackets? Still no, because I got this stupid x out here. So that x must go in there, yes? Does x work with 4? No. So I've got 4, but the x works with x's. And what do I get? 11. Does the x work with y? So what do I get? Y minus 2. Now, can y work with y? What do I get? 1 minus 2. 3. Y to the positive 3. Is positive 3 okay?
Yeah.
Great. What about x and x? Negative 2 minus 11 is negative 13, yes? Right? So I have x to the negative 13. And where's that 4 living? It's already on the bottom. Nothing else to work with him, yes? What of that don't I like?
The negative.
I don't like that. Where do negatives go? What if they're already on the bottom? Then they go up to the top. So what's better to say? Negatives go to the bottom? Or is it better to say negatives reciprocate? Negatives reciprocate. That's why that's what I always say, yes? So that has to go to the bottom, and I get y cubed over 4x 13. There it is. Now, there's 7 laws, yes? But do we really use all 7? It really only comes down to 2 of them, doesn't it? Multiplying and dividing. Because even that law that says the 2 goes to everything inside, that's just the multiply law, isn't it? What about this one? Anything to change on the top? But I better work out the bottom. Where does that 4 go? Everything. So I get 2 to the 4th and x to the 8th, because it's going over brackets, right? What about this one? X to the what? Where does that negative 3 go? Get negative 6. Where does that negative 3 go? Y3. Now please notice that my negatives took care of themselves there, didn't they? So should I have worried about these negatives at the beginning? When should I worry about negative exponents? At the end, in case they don't get taken care of. So it does say x to the 8th, y to the 3, y to the 3. So now what? Are there any other numbers involved? Here, are there any other numbers? No, so it's going to be 2 to the 4th, which is 16, yes? Are there any other x's involved? Right there. What do I do with the 8 and the negative 6? Adam, what is 8 minus 6? X to the 2. Is that a positive exponent? So are we happy with him? Great. What do I do with the y's? They cancel each other out, right? Now, this is a mistake kids make. When you say cancel, you write 0. It's 1. So the only thing left here is a 1. And there it is. Okay? Now, yes, some of these questions took 10 steps. But they're all steps that required you to add, subtract, or multiply, right? Which you learned years ago. Now, the rest of this was really new stuff, right? Like, it wasn't totally fair of me to give you a quiz on it because you hadn't really had a chance to work with it. But that's why I gave it to you as a quiz, right? Because we did that work yesterday. Everyone's like, yeah, we got this, Myers. So, what's this really?
7.
It's 4 times 7, yes? And 4 has what root?
2.
So what comes out? 2. What stayed under there? 7. Done. What's 50 really? You could use 10 and 5, but then you would keep breaking 10 down, right? To get 2 and 5. What do you see right there? Group of 2. So what comes out? 5. What stayed under there? 2. Could you also have done this as the root of 25 times 2? 25 times 2? 25's root is what? 5. So out came a 5 and we left a 2, right? 72. Most of you probably went 8 and 9. And then you say, well, both of them get smaller. And then you probably went 3 and 3 and 4 and 2. And then you could have stopped because 4 has a square root, doesn't it? What is it? So what comes out? 2. Is that a group of 2? So what comes out? 3. What do you do with all the numbers out in front? 6. Root. What did I leave under there? 2. Could I also have done this? The root of 36 times 2. What's the root of 36? So what comes out? 6. 6 root 2. Now we get to something weird. If that wasn't there, would you know how to do that? Okay. And when you did that, you'd get some numbers out in front, wouldn't you? And what would you do with all those numbers out in front? Multiply them together. Well, the only difference is I already had a number out in front there, didn't I? So that's just another thing to multiply. So most of you probably went, okay, well, 512 divides by 2, so that's 256 times 2. And you could have stopped there. Why? 256 is a perfect square. What's the square root of 256 if you'd had all your square roots memorized? 16. So what comes out? 16. What's already out there? So 16 times 6 is 96. Root, what I leave under there? 2. Now, let's say you didn't have your square roots memorized. Then you would just keep breaking this down, wouldn't you? Right? You'd use 2 again. You'd have a frozen computer. And you'd use 2 again. And 128. And then 2 again and 64. And then you could probably stop. Because you would know 64 was 8, right? What? 256. Right? 2 and 128, right? 2 and 64, right? I'm going to stop there because I know 64 has a square root. So out comes an 8, yes? There's a group of 2, right? So out comes a 2, right? And you already had a 6 out there. 8 times 2 is 16. 16 times 6 is 96. 96 out there, and I left that lonely 2 under the radical sign. Attention to detail, right, Sam? You know what you're doing, but you gotta pay attention. All right. What makes number 10 different? There's a negative out in front. What do you do with all the numbers that are out in front? Multiply them together. So, if we add 252, we got to break it down, right? Because if we didn't have this, we know what to do, don't we? So do it. 252 breaks down in 2. It ends in 2. So what should I divide it by? 2. 126. Does that end in an even number? So what should I divide it by? 2. 63. What's 63 break into? 9 and 7. Why can I stop there? 9's got a perfect square. Is that a group of 2? So what comes out? 2. Does 9 have a square root? What is it? So what comes out? 3. What was already out? What's 2 times 3?
6.
What's 6 times 7? 42 with the negative. What did I leave under there? 7. And most of you are doing this without your calculators. What part, Riley? You can't understand the factoring we're doing here? Okay. And then you don't understand that we're looking for a group of 2 here? Groups of 2. 2, 2, there's a group of 2, so I can bring it out. Right? Because I'm looking for things that are too big. 9 breaks down into 3 and 3. There's a second group. I'm only stopping there because I know that the square root of 9 is 3, so I know I can bring a 3 out. Okay? 7 was left over. It doesn't break any smaller. There was already a 7 out front. There was a 7 under there, but there was a 7 out front already. Okay? So, 28 is what? 4 times 7, right? What's the square root of 4?
2.
So what's coming out?
2.
2. What was already out there?
3.
3. What's 2 times 3? 6. And we need it to be negative. What did we leave under there? 7. Okay? Everybody should have been good to there, based on the fact that every time we did a question yesterday, I asked you if you understood, and everybody said yes. Well, not yesterday, but Wednesday. Tuesday. Right? Every single one of you should have been good to there. Now, I did something to you that I don't normally do. I added a situation here that looks different, but in math, do looks matter? If this wasn't there, do you know what to do with that? So do it. What would you do with 448? So Sam went with 8 and 56. And that's okay, but they both break down again, don't they? Into what? 4 and 2. Can he stop there? Because 4's got a perfect square, yes? And this is 8 and 7, yes? He can stop at 7 because 7's prime. What does he have to do with 8? 4 and 2. Can he stop there? Okay. Because what's the square root of 4? 2. So what's coming out to the front? 2. What's the square root there? 2. So what's coming out to the front? 2. Is that a group of 2? So what's coming out to the front? 2. What was already out there? 3. And the whole thing is negative, yes? What's 2 times 2? What's 4 times 2? What's 8 times 3? 24 with a negative in front of it. Can everybody get that far? What did we leave under there? A 7, yes? Everybody cool? Everybody cool? Okay, now, what does... What does U3 and V2 really mean? That means I have 3 U's, yes? And how many V's? 2. What size of group am I looking for? Groups of 2. Are there 2 V's there? So what comes out? A V. Are there 2 U's there? So what comes out? A U. What did I leave under there? A single U. You didn't need me to teach you that because you know that this is looking for groups of 2. Right? This is what makes us math guys angry. Because you do a whole bunch of work and then we change the way it looks and you say you can't do it anymore. That's literally like saying Tasha has 7 apples in front of her. Jashin has 7 apples in front of him. How many apples do they have? 14. Yunji has 8 pears in front of her. James has 6 pears in front of him. Pears do not look like apples. I can't possibly add those. That's exactly what you guys are saying when you come up with that excuse. Does that make any kind of sense to you? So why do you allow yourselves to do that here? How many times do you have to hear from me that math is a series of concepts, not a series of situations? Right? So, again, if the U and the V weren't there, what would we do with 108? We'd break it down. I would break it down into 27 times 4. Why would I use 4? It's got a perfect square. Then I would break 27 down into 3 and 9. Why would I stop there? Perfect square. What's the square root of 3? What's the square root of 9? 3. 3. So what comes out? 3. What's the square root of 4? 2. So what comes out? 2. What was already out? 6. What do I do with everything that's already out? Multiply. What's 3 times 2? 6. What's 6 times 6? 36. What did I leave under there? 3. But that's not all that was under there. How many u's were under there? 1. Is 1 a group of 2? No. So can I take any u's out? No. How many v's are under there? 4. I need 2 groups of 2. How many groups of 2 can I get out of there? 2 groups of 2. So I can get v out once, then I can get v out again. Did I leave any v's under there? No. Would a math guy ever write VV? No. Only if he was trying to draw a vampire, which would have been so much cooler if my computer didn't freeze. Only if he was trying to draw a vampire. Only if he was trying to draw a vampire. Only if he was trying to draw a vampire. Then he might draw 2 V's. But that vampire wouldn't be... Actually, this vampire would be wicked good because he has no nose, so he couldn't smell the garlic.
What if he couldn't smell it? What if he touched it and burned him? Oh, they're like, here, have some bread. He's like, oh, cool, then it's garlic.
So what would he really write instead of VV? 36V squared root 3U. Now, I hope that some of you are seeing a cool little pattern here. What number should be there? 2, which means I'm looking for groups of 2, right? What is 3 divided by 2? 1V, 1U with 1U left over, yes? Right? What is V squared divided by 2? 2 divided by 2 is 1V. Any remainder? Come over to here. There should be a 2 there, yes? Can I divide 2 into 1? No, so it stays there. There's 1 remainder. Can I divide 2 into 4? V2. Now, 14 is no different, except there's a 4 out in front. We know that 3 and 2 are coming out of 108, yes? Right? So what's going to the front here? 3, 2, 4. What's the answer? 24. Groups of 2. How many groups of 2 U's can I get out of there? 2. U squared. How many groups of V's can I get out of there? 2. V squared. What did I leave under there?
Nothing.
No. 3. Now, some of you, I would like to think, maybe figured out 12, 13, and 14. Don't tell me if you did or not. Don't worry about it. But what is important to me is what Sam just said. Do quizzes matter?
No.
Nope. They're not for points. So, am I happier to see a blank page, or am I happier to see somebody try it and get it wrong? Try it and get it wrong. And that's what you should be doing. Because, Sam, what you did there, obviously you said you did it wrong, but what did you try to do? I bet, and I don't mean to interrupt you, but no, tell me what you did.
I just left the exponents.
You left them alone. So you did everything you could have instead of leaving it blank. Yes? Is that a good strategy? Is that a good strategy in life?
No.
Yes, it is. Do everything you possibly can.
Oh, I thought you said leave it blank.
No, leaving it blank is the bad strategy.
No.
Right? Oh, my toilet's clogged.
I didn't see that. What if your toilet floods in? No.
Yes, because the next person will go and flush the toilet and it will flood.
Not exactly.
That's when you get the plunger and you start smacking until it works.
Smacking it.
You said, well,
All right. Everybody good?
never be that.
Everybody good? All right, listen to me. Give yourself a mark out of 14. I'll come around later and I'll get it. And then when you're done doing that, please open to page 101 in your Fireball Fuchsia, no, Outrageous Orchid book.
Yeah, there you go.
Mr. Myers, don't think? So when I got to the number, I started doing like.
You were simplifying it back that way? Yeah. A lot of people in the other class did that too. You never want your numbers bigger, right? The parts that are complicated, like a square root of something, you never want them bigger. All right. Listen up, please. Everybody should be open to page 101, multiplying radicals. Yes. There is, even though it gets its very own heading, there is absolutely nothing on this page that you don't already know. But first, I have to take you on a quick time machine trip of all of math. You walked into kindergarten, and the very first day, Mrs. Bad Crumble started teaching you math. And Mrs. Bad Crumble said, what if our friend Jake had 3 cookies? And you all went, I want some cookies. And Mrs. Bad Crumble said, no, we have no cookies. What if Jake had 3 cookies? I want some cookies. So then Mrs. Bad Crumble realized she couldn't do cookies. So Mrs. Bad Crumble gave Jake 3 blocks. Jake has 3 blocks. And then most of you said, oh, okay, Jake's got 3 blocks. But a few of you were wise asses and went, I want some blocks. And Mrs. Bad Crumble didn't know what to do with you.
I just wanted blocks.
So, that wasn't the point of Mrs. Bad Crumble's discussion. And what Mrs. Bad Crumble should have done was completely ignore the two of you that were like, I want some blocks, and continued to teach math. And then Mrs. Bad Crumble said, Jake's friend James has 3 blocks. How many blocks do they have together? And all of you went, 1, 2, 3, 4, 5 blocks, Mrs. Bad Crumble. Except the two of you, I want some blocks. And those 5 blocks became the basis of math, yes? Right? So the very first year was 5 plus 2. Or, sorry, it was 3 plus 2. Right? Then a couple of years down the road, Mrs. Bad Crumble came along, and Mrs. Bad Crumble said, Jake still has 3 blocks from kindergarten.
Wow.
James still has 2 blocks from kindergarten.
Ooh.
Now, Tasha has 4 blocks. And Sam has 1 block. How many blocks do they all have together?
10.
Exactly. And all of you started doing this. Then you 3, then you 3 more. 1. 10, Mrs. Bad Crumble. And you, gold star. And you were like, I am very good at math. And then Mrs. Bad Crumble said, Nolan has 3 blocks. And Michael has 2 blocks. Now how many? 1, 2, 1, 2, 3, 1, 2, 3 more. What?
You kick off your shoes and pull up the feet.
Mrs. Bad Crumble, I don't know what to do anymore. So Mrs. Bad Crumble taught you multiplying. 5 times 3. Because these guys had 5, those guys had 5, and those guys had 5. And then your world expanded. And then she spent a couple of years dealing with subtraction and a couple of years dealing with division, yes? And then in about grade 6, Mrs. Bad Crumble said, I have some blocks. And you went, how many blocks do you have, Mrs. Bad Crumble? I want some blocks. And she said, yeah, that's how you talked in grade 6. Mrs. Bad Crumble said, I am not telling you how many blocks I have. And you said, well, how are we going to do math? And Mrs. Bad Crumble said, we're going to use letters. And you all went, what? Where is the X finger to count? And Mrs. Bad Crumble explained that I have some blocks, And Jake has some blocks, the same amount of blocks as me. And James has the same amount of blocks as me. And it became 3 times x, which we then cruelly told you was just 3x. We spent a couple of years on that to get you really good with it all. Then in grade 9, we did this. 3x times 2. Yeah. And then you were all like, I don't know. And then we were all like, because by now Mrs. Bad Crumbles kind of moved on. And we said, that's 6x. And then we gave you 1 out of 1 instead of a gold star. Right? And then in grade 10, we went to this. X times x to get x squared. And then we went to 2x times 3x to get 6x squared. And then we went to 2x times 3y to get 6xy. And that, ladies and gentlemen, is your long journey to multiplication in grade 10. All of that happened. All of you understood it. Now, think back to Mrs. Bad Crumble back here. If she had said, James and Jake have 5 blocks. Jake has 2 blocks. How many blocks does James have? X plus 2 equals 5. And Mrs. Bad Crumble could have started you on algebra in kindergarten. Everybody cool? So, all of you took 10 years to get to here.
Yeah, frozen computer, great.
Yeah, to a frozen computer. You took 10 years to get to here. But in that 10 years, you should have gotten good enough to be able to do this, yes? Yeah. Now, did you notice that this principle or the concept carried on all the way through? In this last one here, I was left with a coefficient and what we call a multiplicand. This is multiplied by the coefficient, yes? Agreed? So what would happen to you, do you think, if I had 2 root 3 and I was multiplying it by 3 root 2? What did we do with our coefficients here? Multiplied them. So what will we do with our coefficients here? Multiply them. What did we do with our multiplicands here? Multiplied them. X times y. So what do you think we do with our multiplicands here? Multiply them to get 6. The only difference is there's a radical sign in there now. Okay? So, there is one little rule. You can only multiply if they have the same index. So everybody write that down while my computer thaws. They can only occur if they have the same index. So here's what that means. The square root of x times the square root of y. Is that allowed? Yeah. Why? Because they both have an index of a. So that's okay. Well, the index is the same. Would this be okay? Cube root of x times the root of y. No, because they have different indices. Is everybody cool? Okay. Now, what? I'll get to that right now. Come down to here. You already know how to do this. If this was negative 7x times 5y, what would you do with the 7 and the 5? Multiply them to get what? Negative 35. So what are we going to do with the 7 and the 5 here? Multiply them to get negative 35. What would you do with the x and the y here? Multiply them. So what are you going to do with the radicand and the radicand? Multiply them to get what? 24. Is that a gold star Mrs. Bad Crumble answer?
No.
Why?
Because you can reduce.
Because you can simplify. What is 24 really?
12.
I would use 4 and 6. Why? Because 4's got a perfect square root. What is it? So what's coming out here? 2. What's already out here? Negative 35. So what's out there now? Negative 70. And what did we leave under there? 6. Was there anything new today? It's what you learned in grade 9 and simplifying radicals that you learned in grade 10. 2 days ago. Was there anything new today? So let's try it out. What is my coefficient when there's no coefficient? No, not index, Brianna, coefficient. 1. So what do I do with 1 and 3? Multiply them to get what? 3. As soon as my computer thaws, we'll do that. You guys can go ahead. 1 and 3 gets me 3. And what's under there? What do I do with 2 and 8? Multiply to get what? 16. Is that a Mrs. Bad Crumble answer? No. Why? What's the square root of 16, Nick?
4.
You do, Nick. 4 times 4. So what comes out here? 4. What's already out here? 3. What's 4 times 3? 12. What did I leave under there? Nothing. Square root of 1, right? Which is 1, so we leave it. Done. Everybody cool? What? What's the square root of 16, Brianna? 4. Yeah, because this is telling you to take the number 3 and multiply it by the square root of 16. What is the square root of 16? 4. What's 3 times 4? 12. 12. That's it. It's 12. Because the square root of 16 is 4. Look at the next one. Does it look different?
No.
It looks different, but is it?
No.
Of course not. What do you do with 8 and 6? To get what? Negative 48. Root. What do you do with 6 and 12?
No.
To get what? Is that a Mrs. Bad Crumble answer? No, because of course 72 is 36 times 2, isn't it? What's the square root? It's 36. 6. So what comes out here? 6. 6 times 48 is negative 288. What do we leave under there? 2. What are my coefficients in D? 3 and? So it's, what do I do when I multiply those coefficients? 3. Root 3 and 3? Root 9. What is the root of 9? 3. So that's 3 times 3, which is what? 9. Now this allows me to show you something funke. The root of 3 times the root of 3 is what?
9.
It's the root of 9, right? And the root of 9 is what?
3.
It's not a magic trick, it's math. The root of 9 is 3. What is the root of 2 times the root of 2? The root of 4, which is 2. What is the root of 10 times the root of 10? Root of 100, which is what? 10. What do you notice about root times itself? You get that same number back. 2, 2, 2. 10, 10, 10. So what would happen if I did the root of x times the root of x? It would be x. What would be the root of x squared?
It's X.
It's still x, because the root of x squared is just root x times root x, which is x. Look at you, applying math to something that's new. Stop it! Cut it out, Ethan Anderson!
What did you do?
He applied math in math class.
How so?
Wow. All right. Okay. You all just saw Ethan apply something he knew from the past to something that's new, yes? This right here looks barfy, doesn't it? But if I wrote it this way, 2x times 3y plus 4z plus 5q, what would you do? What would you do with the 2 and the 3? Multiply, because it's just distributive property, isn't it? And what would you do with the x and the y? Multiply them and get xy, right? So what are we going to do here with 5 and 3? Multiply it to get what? 15. And what am I going to do with 8 and 2? Multiply it to get what? 16. Plus, what am I going to do with 5 and 2? Multiply to get 10. What am I going to do with 8 and 3? Multiply them to get 24. What am I going to do with 5 and 1? 5. And what am I going to do with 8 and 5? 40. Is that a Mrs. Bad Crumble answer? Is that a gold star? No. That's a silver star. Because why?
Simplifying.
Because I can simplify it. What is the square root of 16? 4. So out comes a 4. What's already out there? What's 4 15s? 60. Did I leave anything under there? Nope. Plus, what's 24 break down into? 4 and 6. Why'd you use 4? Got a square root. What's the square root of 4? So what comes out there? 2's are out. 10's already there. So it's 20 root what? 6. What's 40? I would use 4 and 10. Does 4 have a square root? What is it? 2. So what comes out? 2. What was already out there? So it's minus 2 times 5. 10. What did I leave under there? 10. Is that a Mrs. Bad Crumble Gold Star answer? Yes. You're damn straight it is. Now we get into trouble. Because there are people in this room whose names I will not mention, but I know who you are. And those are the people that don't actually pay attention to what is happening, and they only pay attention to steps. And I know who those people are. Because when I ask you what you're going to do here, those people are going to do that. So I'm going to stop for a second, let you think about F. Just for a second. What would your first step be? Stop. Okay, that's long enough. I don't want to embarrass anybody, but I am betting there are a few of you in here that did this. 1, 1. 1 times 1 is 1. Cube root, because you saw the cube, and then you did 16 times 54, which is 864. Did some of you do that? I hope not. Because that is a barfy number to simplify, isn't it?
Oh.
Why wouldn't you simplify now? That is 8 times 2, isn't it? Why do they use 8? Because it's a perfect cube this time, right? What's the cube root of 8? 2. So what's coming out? 2. What did I leave in there? 2. What am I going to use here? 27 times 2. Why 27?
27
Has a cube root of what? 3. So what's coming out? 3 cube root 2. Yes? Now, is that easy to deal with? What do I do with the coefficients? 6 cube root 4. Now, some of you should wisely be saying, Myers, right here you said that times that got you the back to here. Why doesn't it work here? Because it's cubed. And I would need 2 times 2 times 2 again, wouldn't I? So that's done. Now, I'm going to shut up and I'm going to ask you to attempt G. Some of you who haven't been paying attention are actually going to go 28 times 63, which is 1,728, and try to break that down. And what am I going to do? I'm going to say quietly, is that the best thing you could do there?
No, but I didn't.
What am I going to be thinking in my head?
You're an idiot.
I'm going to be Nelsoning you from Simpsons, just like TJ did. Go.
Are you done it before you told us that thing? Yeah, so I already broke it.
Yep.
Don't ask.
What's this? What's this? 4 times 7. What happens with the 4?
Perfect square.
So what do I put out front?
2,
10 root 7. What's this?
6, 3,
9 and 7. What comes out?
3,
So it's
6.
9 root 7, yes?
I messed that one up, yeah.
What's 10 times 9? 90. What's root 7 times root 7?
49.
Root 49, which is 7. What's 90 times 7? 630.
Nice.
Now stop. I'm going to give you a present. I am, because apparently presents are what makes you think teachers are great.
No.
Take tonight off.
Yay!
Go home. Don't even think about math. Because believe it or not, even though everything you learned here is something you already knew, you actually had to bring 10 years of math together to make it happen. So I'm giving you the night off.
Can I have a block?
Hey, Angie.
I want some.
What? Yeah. It's still recording. Don't worry.
I want some cookies.
Can I have some cookie blocks? Can we make those?
Cookie blocks.
Yeah, where's that?
What?
Where's that?
I actually make, my kids and myself make gummy bears. And we went to the Lego store
You made Lego.
and we bought Lego ice cube trays in cubes and like the Lego men and stuff. And we made little Lego men gummies and Lego block gummies.
Yeah, I've done that.
What?
Is your boy roasting?
What? Chairs up! Nick! TJ! What?
All the kids
No, because, and here's why. 4 is 2 and 2, but I'm now looking for a group of 3, right? That's only 2. Understand?
Keep it.
But if it was this, 6 square root 4, then you would simplify. Because the square root of 4 is 2.
Yeah.
Cool?
Okay, thank you.
Sorry, just trying to preserve my hair. Oh yeah, nice. Oh yeah, there you go. Team effort. Yeah.
So you're still recording.
Hey, what up? It's me, your boy.
That's a colossal waste of time.
Could Olivia Tatum please come to the office? Olivia Tatum to the office. Thank you.
Fuck off. All right. No.